You know, planets usually dance around their stars, Earth and the Sun, Mars and its golden companion, but out in the depths of the Milky Way, there are lonely wanderers, rogue planets, worlds severed from any sun, just drifting forever in the cold black. They no longer reflect starlight, instead they glow only with the faint heat of their own formation. Out there, temperatures plunge to just a few dozen kelvins. It's like eternal winter under a sky filled with only distant starlight. Yet, surprisingly, these solitary worlds may number in the hundreds of billions, perhaps even two for every star. Tonight, we embark on a voyage into the dark heart of interstellar space. We'll chart how these exiles are born, discover the ingenious tricks astronomers use to glimpse them, and explore the startling possibility that some may harbor hidden oceans and even life far from any star's warmth. Welcome to Skyward Space Quest. Join us as we unravel the mystery of rogue planets drifting alone in space. In the chaos of a young planetary system, orbits shift and collide. Giant planets, some many times the mass of Jupiter, migrate inward or outward through interactions with the protoplanetary disk. In such gravitational dances, one world can be flung outward, beyond its star's grip, at escape velocity. Cast into interstellar space, it becomes a rogue planet. Computer simulations of multi-planet systems show that when three or more gas giants interact, up to half the planets can be ejected. Our own solar system may have lost an ice giant early on, its fate sealed in the Kuiper Belt's orbital scars. But not all rogues begin as ejections. In dark, cold regions between star-forming clouds, dense fragments sometimes collapse under gravity. If the fragment never gathers the critical mass to ignite hydrogen fusion, it cools directly into a sub-brown dwarf, a planet-mass object formed in isolation. These two origins leave subtle fingerprints. An ejected giant may bear scars, irregular spin, moons stripped away, while a formation-alone object shows a more uniform atmosphere and no orbital history. Yet, from afar, both appear as dark orbs drifting without a sun. How do you find a world with no star? The answer lies in gravity and infrared glow. Gravitational microlensing exploits Einstein's prediction that mass bends light. When a rogue planet passes precisely between Earth and a distant background star, its gravity acts like a lens, briefly magnifying the star's light. Telescopes in Chile, known as OGIL, and in New Zealand, called MOA, monitor millions of stars nightly. In 2016, one such survey recorded a quarter-day brightening consistent with an Earth mass lens, our first glimpse of a possible rocky rogue. But not all rogue planets are Earth-like. Young, massive rogues still glow from the heat of formation. Infrared space telescopes, WISE and Spitzer, have uncovered a handful of these faint, cool giants within a few dozen light-years. Their emission peaks at wavelengths invisible to human eyes but clear to infrared detectors, revealing objects drifting through the solar neighborhood. Future missions will expand these methods dramatically. The Nancy Grace Roman Space Telescope, launching in 2027, will microlens hundreds of millions of stars, sensitive down to Mars-mass objects. The Rubin Observatory's Deep Wide Survey will catch long-duration microlensing events from super-Jupiter rogues, and next-generation infrared surveys by Euclid and JWST's successors may directly image the nearest, brightest nomads. Among the best studied is CFB-DESA J21490-403, a world 4 to 7 times Jupiter's mass, drifting about 130 light-years away. Infrared spectra reveal methane and water vapor, signatures of a giant planet's atmosphere unilluminated by any star. Then there's OGIL 2016 BLG1928, the fleeting microlensing event lasting mere hours, hinting at an Earth mass rogue. If confirmed, it would be the first detection of a free-floating, rocky world, proving that even terrestrial planets can be cast adrift. In star-forming regions like Chameleon 1, objects such as SSSPMJ 11027732 blur the line between planet and failed star, with masses hovering near the deuterium-burning limit. Each discovery broadens our understanding. Rogues range from super-Jupiters to Earth-likes to sub-brown dwarfs. Surface temperatures on a rogue planet can plunge below 30 kelvins, freezing any atmosphere solid. But, deep below, heat from radioactive decay and leftover gravitational energy can keep interiors partially molten for billions of years. If a rogue retains even a thin hydrogen atmosphere, say about 1% as dense as Earth's, it could trap internal heat, allowing surface temperatures near water's freezing point. More plausibly, deep subsurface oceans may persist, warmed by hydrothermal vents. On Earth, life thrives around ocean floor vents, powered by chemical energy rather than sunlight. Microbes convert hydrogen, methane, and rock-derived chemicals into biomass. On a rogue planet, similar ecosystems could exist kilometers beneath the ice, forever hidden from starlight. Recent models suggest that a world with mass near 3 Earth masses, carrying a hydrogen envelope, could sustain liquid water under a 100-kilometer ice shell. These hidden oceans transform rogues from frozen wastelands into potential refuges for life in the dark. The discovery of rogue planets expands our definition of habitable worlds. The classic Goldilocks zone around a star, where liquid water can exist, is no longer the only realm where life might thrive. Now we consider dark, self-heated planets as possible cradles of biology. Upcoming missions will probe this possibility. The Roman telescope will amass microlensing statistics, pinning down the frequency of Earth and Mars mass rogues. JWST and its successors could search for thermal emission or even spectral signatures of outgassed molecules, hydrogen, methane, or water vapor, hinting at subsurface activity. If we detect biosignature gases, like methane spikes or chemical disequilibria, in a rogue's atmosphere, it could be our first clue to life beyond the sun's nurturing light. Such a discovery would revolutionize astrobiology, showing that life can flourish in the galaxy's darkest corners. In 1996, a Martian meteorite dubbed ALH 84001, found in Antarctica, shook the world. Inside, researchers spotted microscopic structures resembling fossil bacteria and unusual chemical compounds hinting at life's building blocks. Headlines proclaimed the first proof of extraterrestrial life. President Bill Clinton announced the findings at the White House, but skeptics pointed out that shock and heat from ejection could produce similar features. Eventually, most scientists deemed the evidence inconclusive, yet the episode galvanized a generation of astrobiologists and propelled missions to Mars with life detection goals. It underscored how ambiguous clues can spark bold exploration, and how rigor is essential when interpreting scant signals of life. Rogue planets reshape our cosmic perspective. They challenge the notion that life can only exist in a narrow band around a star. They inform planetary formation theories. How often do systems eject planets? Did our own solar family lose worlds in its youth? Rogue census also refines dark matter studies. Compact objects in the galactic halo can masquerade as microlenses. By distinguishing planetary mass lenses from stellar or substellar ones, we sharpen our understanding of the galaxy's unseen mass. Finally, rogue worlds beckon future explorers. Interstellar travel proposals envision using free-floating planets as way stations, cold, dark harbors where a passing ship can mine water and fuel without the hazards of a stellar environment. In the glowing band of the Milky Way, among the brilliance of stars, lie shadowed worlds we cannot see. Rogue planets drifting through the void, each with its own story of birth, exile, and possible hidden oceans. Some are giants still glowing from youth, others are ice-cold and ancient, but all remind us that the galaxy is richer and far more mysterious than starlight alone reveals. As our telescopes and surveys advance, we will map these secret nomads, unveil their numbers, and perhaps glimpse the first signs of life in the eternal night. The dark between stars is not empty. It teems with worlds waiting to be discovered. This is Skyward Space Quest. If this journey into the Milky Way's hidden wanderers stirred your curiosity, please like, subscribe, and join us next time as we continue exploring the wonders of the cosmos.